A scratched CD that never skips, and a spacecraft calling home from outside the solar system are running the exact same trick. Both of them are surrounded by noise, physical damage, or 25 billion kilometers of empty space, and both of them get the original message back perfectly anyway. The trick is called error correction, extra data added on purpose and arranged with real structure so a reader can catch damage and rebuild exactly what was lost, without ever asking for a repeat. The obvious fix is just sending everything 3 times and taking the majority vote. It works, but it triples the size of everything you send, for a problem that's usually much smaller than one whole extra copy. Hamming codes do it far more cheaply. Take 4 bits of real data, add 3 check bits at specific positions, and you can find and fix a single flipped bit using only 3 extra bits, not 4. Here's the clever part. Each check bit watches a different, overlapping group of data bits. Flip any one bit, and the specific combination of checks that break literally spells out its position in binary. That's perfect for the kind of error you'd get from random electrical noise or a stray cosmic ray. 1 bit, flipped in isolation, anywhere in the message. A scratch on a disk is nothing like that. It doesn't flip one random bit. It wipes out thousands of bits in a row, all clustered in exactly one place. So disks use a different code, Reed-Solomon, that works on whole chunks of data at a time instead of single bits, built specifically to shrug off one burst of damage, not scattered single flips. Then comes the real trick. Before anything is written to the disk, the data is scrambled and spread out, so a scratch that looks continuous on the plastic actually lands on many small, separate, independently fixable gaps. Put it together, and a CD can survive several millimeters of scratched, unreadable plastic and still play the music underneath without a single audible skip. Take that same idea and push it to its absolute limit, and you get how we still hear from Voyager, a machine that left the solar system decades ago and has never stopped talking. It's over 25 billion kilometers away, broadcasting on about 20 watts, less power than a refrigerator light bulb. By the time that signal reaches Earth's dish, it's 1 billion times weaker than a GPS satellite's. That signal now takes over 23 hours to arrive, one way, and it carries data slower than an old dial-up modem, around 160 bits every second. Early in the mission, Voyager's error correction cost as much extra data as the real data itself, a full 100% overhead. Before it reached Neptune, engineers rewrote that code from 4 billion miles away. The new Reed-Solomon-based code cut that overhead down to 20%, while making the error rate roughly 5 times better, from about 5 mistakes per 100,000 bits down to 1 per million. A 4 billion mile software update and a CD surviving your car's cup holder are solving the exact same problem. Expect the noise before it happens and build the math to survive it.